All right, welcome to the pre-cal session. I hope everyone had a good weekend last week. So, um, the exam, the exam grade will be coming soon. I haven't been grading it yet. I think this time most of the grades are auto graded by the Lumen. Um, uh, there are just some questions that I need to grade it manually. All right. Before we start, any questions? Uh, there will be another exam, the last exam, exam 4. That happens. That happens on. It's gonna be on May the 12th. May the 12th, which is a Tuesday. Which is a Tuesday. And the final exam is also gonna to be on Lumen as well. It's gonna happen on the uniform exam day. All right, the department put it on the reading day. If you have a scheduled conflict with other exams, departments usually put the uniform departmental exams final on the reading day, and sometimes if you have classes that have uniform exams together, they tend to sometimes have a conflict, so you might need to contact the register to reschedule, something like that. But nonetheless, it's going to be held on May the 15th on Friday from 11 to 1. So let me put it here. 4. Okay. Right, any questions? Whew. Okay. So today we will be engaging. Yeah. What time will the final be again? Okay. For the final is the final is from 11 a.m. to 1 p.m. And exam 4 is the same as the class time, 3 p.m. and to 5 p.m. Right? Okay. So today we'll be engaging the last section in this class, which is sequences and series. I I find it, this concept rather be very abstract. Right? It deals with indexes and uh, um, patterns a lot rather than the numbers that we do before, like functions. So it's gonna be a little bit abstract, I think. Um, the hard part for this is usually the idea of having an index rather than having a like a functions. We have a concrete term, but in this case, the sequences, the indexes is rather abstract. Right. So but we have dealt with indices before, All right, so remember how we define a polynomial, px, right? You have coefficient and some power of x, right? You have another coefficient with another power of x, and you add them together all the way to the coefficient for the first power of x, and finally the zero power of x, which is a constant. So in this case, you have a list of coefficients, and when you put the coefficient together, it forms a list, right? It's not just a list, it has an order, right? Because the first number here refers to the coefficient for the constant term. This one corresponds to the coefficient for the first power term, all the way to the last number when it corresponds to the coefficient for the nth power term. So you have an order list. So we call this a sequence. So this is called a sequence. And this number, which denotes its position, right? Think of sequence as you have a queue, and then you have a bunch of people lining up, right? And then you put an order, you put a number for each person, right? So this number is called index, right? So it denotes its position, right? So with that number, you will know that this is the what is its position, and from that you can have that it corresponds to the coefficient to which power of x, right? So let's get a little bit formal for that. Is that the index is always a natural numbers, right? It's always a integers, positive integers, or zero, right? It could start at zero. And it increase by 1. So no matter what number you start with, you might start with 0. Sometimes you might start with 1. All right, but it always the next one is always 1 larger than the next one. You can't skip over numbers, right? It always go in line, right? So for example, if you have a sequence an, you start with a1, a2 all the way. For n greater than or equal to 0, then the a1 here is the first term in the sequence. A2 here is the second term. In the sequence, right? And the 8k term is the kth term in the sequence, right? Because that's how we index these numbers in the sequence, right? Because we start with 1, the first one would be the A1, second one would be A2, third one would be A3, and for AK, it refers to the kth number. However, if we start with A0, then the first term becomes A0, the second term becomes A1, and when you have AK, it's actually the K plus 1th term. Because you start with 0, you have one extra term. Right. So let's do some exercise. All right, so for the first question, you have a polynomial. So for this one, you have a power 2 polynomial. So for general power 2 polynomial, you start with A2, that corresponds to the power for x squared, plus A1 times the power for x. Finally, you have A0 for the constant term. So in this case, A2 here would be 3. A1 here is minus 2. And A0 here would be 1. And this forms a sequence, right? If we write it down as AN, then you start with 1, followed by minus 2, then 3. Okay. So for this one, you have an 8th power polynomial. However, it doesn't have all the terms for all the powers of x. Instead, it only has power 1, power 4, and power 8. Right? So you only have A0 is 1, A4 is minus 5, and A8 is 6. And the others are all 0. A1 are 0, A2 are 0, A6 is 0, A7 is 0, etc. etc. The only non-zero terms are 1, minus 5, 6 for A0, A4, and A8. Right? So when you have a sequence, you have 1, therefore A0, A1 is 0, A2 is 0, A3 is 0, A4 is not 0, so minus 5, A5 is 0, A6 is 0, A7 is 0, but A8 is 6. So this is the sequence for the coefficients of the polynomial for question part B. For part C, you have the constant term is 4, and A10, it has the 10 power, that is 10, and the rest is 0. So it becomes 4, A1 is 0, A2 is 0, A3 is 0, A4 is 0, A5 is 0, A6 is 0, A7 is 0, A8 is 0, A9 is 0, but A10 is 1. Oops, I think this is 1. All right. Finally, for the last one, you have only power 1 polynomial, so in this case power is 1. A0 is minus 1, A1 is 1. So the sequence becomes minus 1 and 1. All right. So far, so good. All right. So for the sequence of polynomials of a sequence of coefficient for polynomial, this sequence has no pattern. All right, it corresponds to the coefficient to the polynomial. The numbers can be anything. All right, it jumps around. But oftentimes when we have a sequence, it has a pattern. All right, and it's called the general form, or the general formula for each term. Okay, so when you have n, sometimes you have a general term. That means think of it kind of like a function, right? And then you only input the natural number into it, and the outputs of it becomes the number in the sequence. All right, so like a n is f of n, where n is natural number. So for example, if you have the general term as a n is equal to 2n plus 1, that is the general term for a sequence a n. So let's start with the let's see what are the first 5 terms where you begins from 0, right? So for the first 5 terms is a0, a1, a2, a3, and a4. right? So when you plug in 0 into this general term, 2 times 0 plus 1 is 1. For the second term, you plug in 1 into this general term. 2 times 1 plus 1 becomes 3. For 2, you plug in 2 into the general term. 2 times 2 plus 1 is 5. For 3, 2 times 3 plus 1 becomes 7. And for 4, 2 times 4 plus 1 is 9. So the first 5 terms for this sequence is 1, 3, 5, 7, 9. Okay. Right. Let's do another one. So in this case, we have the sequence Bn. General term reads 2 to the nth power plus 1. For the sequence Bn. And then you also start from 0. Okay. Then for the first 5 term, B0 is because it starts from 0. B1, B2, B3, and B4. The first one, B0, when you plug in 0 into the general term, 2 to the 0 power plus 1, 2 to the 0 power is 1, so 1 plus 1 is 2. For the second one, 2 to the first power plus 1, well, 2 to the first power is 2, so plus 1 is 3. The third one, 2 to the second power plus 1 is 5. The fourth one, 2 to the 8th power, which is 8, plus 1 is 9. The last one, well, the fifth one, 2 to the 4th power plus 1, which is 17 plus 16 plus 1, you get 17. Okay. All right, so let's do some exercise. Right, write out the first 5 terms for the following sequences. It all start from 0. Right? This is uh, this is minus 1 to the nth power. This is n. It should be the first 5 terms. This is 5. Right, let's going over this exercise. The first one is minus 1 to the nth power n squared over n plus 1. For the first 5 terms that start from n equal to 0. So you start from A0, then A1, then A2, A3, and A4. Right, for A0, minus 1 to the 0 times 0 squared over 0 plus 1. Well, minus 1 to the 0 is 1. 0 squared, however, is 0. So 1 times 0 is 0. Right. For the second one, minus 1 to the first power times 1 squared divided by 1 plus 1. Minus 1 to the first power is minus 1. 1 squared is 1, so it becomes minus 1 over 2. The third one, minus 1 to the second power times 2 squared divided by 2 plus 1. Minus 1 squared is 1. 2 to the second power is 4. So the numerator is 1 times 4, which is 4. The denominator is 2 plus 1, which is 2. So 3. So the result is 4 over 3. 3 minus 1 to the third power times 3 squared divided by 3 plus 1. You should get minus 9 over 4. And for the last one, you have minus 4 to the fourth power times 4 squared divided by 4 plus 1. The result should be 16 over 5. Right? Any questions? For the next one, you have Cn equals n to the 2n power minus 5 to the nth power to the as the denominator. For the first 5 terms that start from n equal to 0, you start with A0. So 0 times 2 to the 0 divided by 5 minus 5 to the 0 power. 2 to the 0 power is 1, minus 5 to the 0 power is also 1. So the numerator is 0 over 1, which is 0. A1 is 1 times 2 to the first power minus 5 to the first power, which is minus 2 over 5. A2 is 2 times 2 to the second power divided by minus 5 squared. Then you have 8 over 25. A3 is 3 times 2 to the third power divided by minus 5 to the third power. You should have 24 divided by minus 24 divided by 125. A4 is 4 times 2 to the fourth divided by minus 5 to the fourth power. You should get 64 divided by 625. Okay. Any questions? All right. So in general, there are certain kinds of special sequences. We have special names for it. Right. The first one is called arithmetic sequence. So you have a sequence of numbers right. the pattern for arithmetic sequence is that they have common difference. So the difference between the current term and the preceding term is the same as the difference for the next term and the next term. So the difference between these two terms is D. The difference between these two terms is also D. Right? For any two numbers that are next to each other, the difference between these two numbers is always the same. Okay. So for example, if you have the sequence of number with 1, 3, 5, 7, 9, 11, etc., right? You notice that the difference between 1 and 3 is 2. Between 3 and 5 is also 2. 5 and 7 is also 2. So this is a arithmetic sequence. Right? So to recognize whether or not you have a arithmetic sequence, you just look at the difference between each two terms and to see if they are equal or not. So example, -17, -8, 1, 10, 19, etc. Okay. So in this case, from -18 to -8, the difference is 9. From -8 to 1 is also 9. From 1 to 10 is 9. 10 to 19 is also 9. So the differences are all the same. So this is an arithmetic sequence. Okay. So how do we write down the general term for it? Right. So you have the starting term 17. All right. So and we call it A0. Right. We start with A0. And for the nth term, for an, that means you have n plus 1 term, right? Because you start from 0. And how many differences does it go through? For the first one, here you went through 1 difference here. For the second one, well, for A2, this is the third one, sorry. You went through 2 differences, right? So for AN, you goes through n numbers of differences. So you just add n times the difference. From your starting term A0. Okay, so let's plug in the numbers. 17 for A0. Your common difference is 9, so 9n. All right, let's put it in the right number. Okay. So in this case, an is your first term. I mean, a0 is your first term. Okay. So for the next one, 50, 44, 47, 44, 41, 38. Okay, so let's look for the difference. From 50 to 47, the difference is minus 3. 47 to 44 is also minus 3. 44 to 41 is minus 3. 41 to 38 is also minus 3. So the differences are all the same. This is an arithmetic sequence. So let's write down the general term. Okay. The first term is 50. Right? That is a 0. An, you go from 50 and you went through n numbers of differences. So plus minus 3, which that's the common difference, times n. Well, simplify this, you have 50 minus 3n. Okay. Any questions? All right, so let's do some exercise. For the following sequences, write down the general term. So let's go over this. So the general term, A0 is 5, AN is 5, the common difference is 3 for this arithmetic sequence, so plus 3n. Okay. Now, the next kind of sequences is called geometric sequence. So for geometric sequences, instead of having a common difference, now you have common ratio. So the ratio between the current term and the preceding term is the same as the next term with the current term. So put it this way, you have A0, A1, A2, AN, like that. So the ratio between these two numbers is the same as the ratio between these two numbers, and would be the same as AN over AN minus 1. So from the current term to the last term. Okay, so how do we write down the general term for this geometric sequence? All right, so if you start from A0, okay, then for the nth term, you apply how many factors, how many powers of the common ratio, right? Because the A1 is A0 times this common ratio, and A2 is A1 times this common ratio. So for A2, you actually apply 2 powers of this common ratio from your A0, from the starting term. So from A0 to A1, you apply 1 power of R. From A1 to A2, you also apply 1 power of R from A1. So in general, from A0 to A2, you actually apply 2 powers of R. Right? So for AN, now you apply n powers of this common ratio from your starting term A0. Okay. Right, so let's do some exercise. Right, let's see some examples. All right, so for example, if you have a sequence that's 1, 3, 9, 27, 81, etc., etc. Right? So let's look at their ratio. From 1 to 3, the ratio 3 to 1 is 3. From 3 to 9, the ratio is also 3. 9 to 27 is 3. 27 to 81 is also 3. Okay. So in this case, the common ratio is 3. And your starting term is 1. So to write down the general term AN, you apply n powers of 3 to a 1, which is 1. So a n is 3 to the nth power. Okay. For the next one, if you have 4, 8, 16, 32, 64, right? In this case, the common ratio is 2. Right. So for the general term, a0 is 4, the ratio is 2. So an is 4 times 2 to the n power. Right? You can simplify this because 4 is 2 to the second power, and you apply the product rule for the power, so 2 to the n plus 2 power. All right. For the next one, 4, 2, 1, 1/2, 1/4, etc. Okay, so in this case, the common power is common ratio is 1/2. Okay, then for the general term, in this case, you start from 4, but the ratio is 1/2, right? Instead of a number greater than 1, so you have a decreasing power. So an is 4 times 1/2 to the nth power. Well, 1/2 is 2 to the minus 1 power, and 4 is 2 to the second power. Okay. So using product rule, adding 2n minus n together, you have 2 to the 2 minus n power. Okay. Any questions? All right. So with these two general, special. Oh, there's another kind of sequences. It's called alternating sequences. All right. So for alternating sequences, you have positive for this term, negative for the next one. So for example, you have 4 and then minus 2, and then positive 1 minus 1/2, positive 1/4. Right. So for alternating sequences, you just have an extra minus 1 power applied to the general term of for this sequence, right? So if you forget about the minus signs, right? This is 4, 2, 1, 1/2, 1/4, etc. When you get rid of the signs, or if, just ignore the sign for a while. This is a geometric sequences, right? With the common difference 1/2, starting term 4. Right? So 4 times the general term for this geometric sequence is 4 to the 1/2 to the nth power. So it's 2 to the 2 minus n. All right, so let's go back when you have to consider the minus sign, right? So in this case, you have a 0 with a positive sign, a 1 with a negative sign, a 2 now come back to positive. So you notice that for the even terms, which is 0, 2, 4, etc. So even terms is positive. Odd terms, however, on the other hand, is negative. All right. So that means you have to apply -1 to the n power, right? Because even for n is even, -1 to any even powers is positive. If it's n is odd, then -1 to the odd power becomes negative. So you apply this extra factor to the general term here, becomes -1 to the n power 2 to the 2 minus n. All right. So this is alternating sequence. So let's combine everything together. All right. So if you have a sequence, all right, that utilizes all this kind of special sequence, right? So for example, if you have a sequence -2 to the over 5, 3 to the 10, 3 over 10, -4 over 17, 5 to the 26, etc., etc. -2 over 5, 3 over 10, -4 over 17, 5 over 26, 6 -6 over 37. So, right. So in this case, when you look at the difference, right, they don't have common difference. When you look at the ratio, it doesn't have common ratio either. Right? It seems like you don't have any clue on what kind of sequence this is. But if you break it down into fractions, all right? So you look at the numerator of the fractions and the denominator of the fractions, it actually have patterns for each. Right? So let's start with the numerator. You have 2, 3, 4, 5, 6. All right. Then they have common difference, right? The difference from 2 to 3 is 1. From 3 to 2 is also 1. 4 to 5 is 1. And this is the same across all the terms. So this is arithmetic sequence. Right? With the starting term 2, common difference 1. So now we can have the general term for the numerator 2 plus 1 times n, which is 2 plus n. All right. Now let's look at the denominator. 5, 10, 17, 27, and 37. for this case, it's a little bit hard to spot, right? They don't have common difference, nor they have common ratio. But you notice that is actually 1 plus a complete square. So for 5, it's actually 1 plus 4. For 10 is 1 plus 9. 17 is 1 plus 16. 26 is 1 plus 25. And 37 is 1 plus 36. All right. And 4, 9, 16, 25, and 36, they are all complete square. Right. 4 is 2 square, 9 is 3 square, etc., etc. So if you have the starting term 5, which is 1 plus 2 square, then an would be 1 plus n plus 2 square. All right. So now the last thing to notice is that you have -1, a minus sign alternating. So you have -1 for the first, for A0, but positive sign for A1. So the pattern here is that you have, for even terms, you have minus sign, and for odd term, you have positive sign. So you have to apply -1 to the n plus 1 power instead of n, like we did before, to the whatever pattern we find out for the fractions. Because for even, you have negative. So you have to switch from, even to odd by adding 1 to the power. Now -1 to the n plus 1 would become a negative because n plus 1 is odd. So for odd terms, n plus 1 is even, so -1 to the even power becomes positive. Right? It matches our pattern. Right. So in general, you have this, and this, right? This is numerator, this is denominator, and this is the sign before that fraction. So combine everything together. You have -1 to the n plus 1 power. The numerator is an arithmetic sequence that has general form 2 plus n. The denominator is 1 plus a complete square, so n plus 2 square. So this is the general term an. All right. And let's do another one. 5 over 3, 5 over 9, 5 over 27, 5 over 81. All right. So in this case, when you notice that the ratio from the current term to the next term is actually the same as the next term to the next term. From 5 to 5 over 3, the ratio is 1 over 3. From 5 over 3 to 5 over 9 is also 1 over 3. So now you have a common ratio. This is a geometric sequence. You have the starting term 5. The common ratio is 1/3. Then the general term an is 5 times 1 over 3 to the nth power, which is 5 over 3 to the n. This is rather easy. Let's do an exercise. Minus 4 over 3, minus 11 over 7, minus 30 over 11, minus 67 to 15, and minus 128 to 19 over 19. So find an. We'll start from 0. So the hint here is that you break it down into numerator and denominator, and you find out the pattern for the numerators and denominators separately. Right. So for the denominator, it shouldn't be hard for you to spot the pattern, but for the numerator, for the top part, the hint here is you look at the number that has 3 less than the number of the numerator, and maybe you can find the pattern. Let's go over this. So for the numerator is 4, 11, 30, 67, and 128. Right. So when you look at the number that are 3 less than this number is 1, 8, 27, 64, and 125. And the pattern for these numbers are they are cubic numbers. Right. 1 is 1 to the cubic power, 8 is 2 to the cubic power, 27 is 3 to the cubic power, and etc. etc. So the general term for the numerator an is actually 3 plus, if you start from 0, then this is n plus 1 cube. Okay. For the denominator, well, is 3, 7, 11, 15, and 19. Right? Then they all have common difference, 4. So you have common difference is 4. You start with 3. So the general term is 3 plus 4n. All right. And there is a negative sign in front of the fraction. So in general, an is minus, well, the general term for the numerator, 3 plus n plus 1 to the third. I should use different numbering. So the numerator, we call it Bn, and for the denominator, we call it Cn. Right, so the general term for the denominator is 3 plus 4n. Okay. Any questions? All right. The last thing I'm going to go over is called factorials. All right, so factorial looks something like this. Right? You have a number followed by a symbol that looks like a exclamation mark. Right? It's not an exclamation mark. You don't have you know emphasis on the number n. Instead, it means factorial. Right? So what does it mean to have a factorial? So you have a so basically you have a, what do you call it, the product of n numbers starting from n followed by 1 less than n followed by 2 less than n all the way to 2 and 1. Okay. So for example, if you have a full factorial, then you start from 4 times 3 times 2 times 1. Right, 4 times 3, you get 12. 12 times 2, you get 24. 24 times 1, you get 24. So that is the result for 4 factorial. Right? Let's get rid of this one. So another example would be 5 factorial, which is 5 times 4 times 3 times 2 times 1. The result should be 120. Right? So what if you have a fraction with factorials? Right? So you just do the factorials for both the numerators and the denominators. So 7 factorial becomes 7 times 6 times 5 times 4 times 3 times 2 times 1. And the denominator is 5 times 4 times 3 times 2 times 1. And when you do the calculation, you should have 120 at the denominator and 5040 as the numerator. Right, let me make sure. Yep, 5040 as the numerator. Right. So let's do some exercise. So let's find out what is 8 factorial and what is 7 factorial divided by 10 factorial. one quick thing to add on for the last example. For the last example, you have 7 factorial over 5 factorial. Right. When you write out the terms, you can actually have cancellations. Right? Because there were, common factor of 1, common factor of 2, 3, 4, and 5. So when you cross out the terms, you only have 7 times 6, which is 42. So for this case, for the second one, you have, when you write out the terms, right, divided by 10 factorial, just expand the terms, right? Then you can have cancellations, right? You have 1, you have 2, you have 3, you have 4, 5, 6, and 7. What is left over is 1 on the numerator, 10 times 9 times 8 in your denominator. So the result is 1 over 720. Right? So for the first one, a factorial, you just expand the factorial. Right? The result should be 4320. Right. Okay, so now that you have factorials, then what if you have factorials in your sequence, right? So for example, if you have the general term as 2 to the nth power divided by n factorial, all right, then you just, when you want to find out what are the first 5 terms, for the for this sequence, right? Then you just plug in n equals to 0, n equals to 1, and 2 for the sequence. Oh, one more thing to add on for the factorial is that 0 factorial, right, is always 1. Right, that is the convention, right? Otherwise, it doesn't make sense. Right? So for a0, 0, 2 to the 0 power divided by 0 factorial. Well, 2 to the 0 power is 1. 0 factorial is also 1, so 1 over 1 becomes 1. For a1, 2 to the first power divided by 1 factorial, which is 2 over 1, which is 2. A2 is 2 squared over 2 factorial, which is 4 over 2, which is 2. A3 is 8 over 3 factorial, which is 6, so 4 over 3. A4 is 2 to the 4th power over 4 factorial, which is 16 over 24. You simplified it to be 2 over 3. Right? So for the next one, you have a general term for a sequence like this, which start from 0, and when you find out what are the first 5 terms for this sequence, you just plug in the indices into the general term, right? B0, which is -1 to the 0 power, times 0 factorial over 2 times 0 factorial, right? Well, -1 to the 0 power is 1. 0 factorial is also 1, so the numerator is 1 times 1. 2 times 0 is 0. 0 factorial is also 1. So the result is 1. B1. So now you plug in n equals to 1 here. And n factorial is 1 factorial. 2 times 2n is 2 times 1 factorial. Right? 1 factorial is 1. 2 factorial is 2. So -1 to the first power is -1. So -1 times 1 divided by 2, which is -1/2. Right? For B2, -1 square 2 factorial times 2 times 2 factorial, which is 1 times 2 over 24. You simplified it to be 1 over 12. Right? For 1b3, you plug in 3. Right? Now you simplify. -1 over 120. And B4 is -1 to the 4th power, 4 factorial divided by 8 factorial. And now it becomes 1680 in the denominator. All right. All right. Let's do some exercise. So find out the first 3 terms for the sequence an is equal to -1 to the n plus 1 power. 2 to the n divided by n plus 1 factorial, where n is greater than or equal to 0, meaning it starts from 0. Let's score this. Right. The general term reads, and this is n plus 1 to the 2 to the n power divided by n plus 1 factorial. So if you start from 0, you have A0, A1, A2 for the first 3 terms. Right? For A0, you just plug in n equal to 0. For n. Okay, so now 0 plus 1 is 1, so minus 1 to the first power times 2 to the 0 power divided by 1 factorial. Right? Simplify each term. Minus 1 to the first power is minus 1. 2 to the 0 power is 1. 1 factorial is also 1. So the result is minus 1. So the next one is minus 1 to the 1 plus 1 power times 2 to the first power divided by 1 plus 1 factorial. Simplify this is minus 1 squared divided by 2 to the first power times 2 to the first power divided by 2 factorial. Right. Simplify each term. You should have 1 as your result. So for A2, you should have minus 1 to the third power times 2 to the square divided by 3 factorial. And the result should be minus 2 over 3. Okay. Any questions? All right. Okay. If there's no question, class is dismissed, and see you guys on Thursday.